So we've been learning for a whole month now. You guys understand it's already February, right? We have been learning all of January. So we've learned so much in the month that we've been going that I think for some of you it's starting to all blend. Like you have no idea what's formulas for this or that. So you've got to get this picture in your head and know it. It's going to take some studying and memorization. Like that's just one thing in math. It just comes with doing math. So remember that one of the first things we learned was how to find the axis of symmetry, and that's with graphing, right? It was this formula. X is equal to the opposite of b over 2a. You cannot use that formula for anything other than finding the axis of symmetry. You've got to just know that. Do you understand what I'm saying? This is the formula to find the axis of symmetry, and that's when we're graphing a quadratic. Now, let's say we're not graphing a quadratic. Let's say that we're solving, and I say solve by completing the square. You know you're taking it from standard form to vertex form. If you see the words completing the square, or even, if you see the words completing the square, it's always this formula. You take b divided by 2 squared. Now look how similar they look. Kind of similar, right? Easy to get them confused, but you've got to just memorize which one's which. So if you're completing the square, you take b divided by 2 squared, and then it's a whole process, right, everybody? Do you get what I'm saying? I'm trying to help you, and you're all just kind of staring into the abyss. Okay. And then if we want to solve, totally different thing, having nothing to do with either or, if we want to solve using the quadratic formula, it's that formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. But we use parentheses and stuff. Now, you've just got, some of you still don't have this memorized, but I have no idea how you don't. You've got to have it memorized. You have to have all of them memorized, and you have to know which one goes with which. So if it was me, I would have been writing this down in my notes so that tomorrow, and when you get the review, you don't say to me, I've never learned this, I don't know which one to do.
We can do
refer back.
These notes.
On the test reviews? Absolutely. That's why we take notes, is so that you can successfully do the test review. Yes?
What's t times f?
Quadratic formula. Yeah. Let's get going on what we're learning today. Okay, so first of all, I wanted to review how to factor something like this, because a lot of you, you're doing it the way hard way, and you've got to go back to doing it the easier way. So everybody, solve by factoring. X squared plus 2x. Are we missing the x?
Yeah.
Are we?
No.
No, we have the x, but look, don't say, okay, so c is 0. That is true, but don't look at it that way. You're right, c is 0. But if we're solving by factoring, what's there in common right here, right now?
X.
So let's factor out an x. So when I factor out an x, I go back and say, well, what? When I factored out the x, what's left when I factored out the x? X squared divided by x. So x plus 2. Now look, aren't these linear factors? Linear, guys, means degree 1.
Yeah.
Aren't they degree 1? We factor down to linear factors and set them equal to 0. So aren't we done? Wasn't that 10 times easier than trying to do what multiplies to be a times c and adds up to be b? So now we would set our linear factors equal to 0, and the zero product property rule says we set each of those linear factors equal to 0 and solve. So we have x is equal to 0, no solving involved. Minus 2, x is equal to negative 2, guys. We have our two answers, that quick, that easy. If I see this in the future, I expect you to really remember how to do this.
X is equal to 0.
Yeah.
Set that equal to 0, that's a linear factor. X is equal to 0. Set x plus 2 equal to 0. Solve for x in each case. What confuses you about x is equal to 0?
Split off of 2.
Well, the zero product property rule allows us to set each linear factor equal to 0, right? So we set this equal to 0, and we set this equal to 0. This is a linear factor, just like any other factor. Jordan, you don't get it, so you need to say, I don't get it, and ask for help.
No, I'm trying to get it now. Think.
If you needed to, that's the same thing as x plus 0. So x plus 0 is equal to 0, so x is equal to 0.
Okay.
So do you see how it's still a linear factor?
Yeah.
Okay, next one. So we have x squared is equal to 25x. First of all, before we can even solve, we have to get it set equal to 0. So I subtract 25x. So we have x squared minus 25x is equal to 0, right? Now don't try to say, well, multiply to be a times c. Or if you do that and you're like, oh, my c value is 0, say, oh, was there something in common in the beginning? Yes, there is. What's in common? So I'm factoring out x. Divide each term by x. What's left? x minus 25. Now look, a linear factor. Set each linear factor equal to 0 and solve. So I'm setting that linear factor equal to 0. I'm setting that linear factor equal to 0. Then solve for x in each case. Solving for x is done. Add 25, right? So x is equal to 25. Questions on that? Okay, what about this one? Is my c value 0?
Yep.
So let's check. Is there something in common we can factor out right here?
Okay.
Yeah, we can factor out an x, but there's something even greater. What? So let's factor out 5x. So divide each term by what you factored out. So what's 5x squared divided by x? 5x, sorry. X. That's 25x divided by 5x. So plus 5. Now, aren't these linear factors? Yeah, so set each of them equal to 0. So we have 5x is equal to 0. We have x plus 5 is equal to 0. And solve for x in each case. To get x alone, you divide both sides by 5. What's 0 divided by 5? 0. And we'll subtract 5, so x is equal to negative 5. So guys, in the future, if you have if you have a ax squared and a bx, you can always factor out an x. Do it that way. Yeah.
Will it always equal 0? One of the x's?
If this is the case, then yes. Good question. All right, but don't mistake that with something like this. X squared minus 49, right? That's missing bx, right? So it's not the same thing. You'd isolate x squared, solve for x, right? Okay. All right, so tomorrow we're going to be putting it all together, reviewing for the test. So make sure you come with your notes ready to go. All right, so let's do today's lesson. So today in 6-11, we're going to be dealing with circles in the coordinate plane. So a couple things to understand. The parent function is x squared plus y squared is equal to the radius squared. So this is the equation of a circle. And parent function, I had somebody ask me that. Remember, parent function means the most basic non-shifted function. So x squared plus y squared is equal to our radius squared. So, if you think about it, the reason it goes in our quadratic units is because these squares are what make our circle happen here. So just keep that in mind. So we have x squared plus y squared is equal to the radius squared. Does everybody see the formula here? Or the equation? Okay, so we're just getting familiar with what a circle looks like. I'm not asking you to do anything with this yet. So understand something about a circle. This is the parent function, means non-shifted function. The center of your circle will be at 0, 0. So does everybody see how right here I have the center of my circle at 0, 0?
It will always be there?
If it's the parent function, so it's a non-shifted function. No, we're going to take and move this circle all over the place in a second. It won't always be that at 0, 0, but that's where it started. Does that make sense? All right, and then our radius, it could be anything. So I just drew a round circle, but do you guys understand that from here to here is a radius?
Yeah.
Here to here is a radius. Is everybody comfortable with that? Now, understand the full length is called a diameter, so then half the diameter is the radius, right, everybody? So just keep that in mind. You should know that by now. All right, awesome. Okay, so now this is what you'll want to write down. So now we're going to be dealing with shifted circles. So we're taking our parent function and shifting it, and this is what the equation is going to look like. So we have x minus h squared plus y minus k squared is equal to the radius squared. So the difference is the shift on our horizon and shift up and down. So this is what you've got to understand. Anything added inside with x is your shift left and right. Because it's in parentheses, you always go opposite. So this is our shift left and right, and we're going to go the opposite of the sign. So x values are what shifts our circle left and right. Okay? And then this y is what shifts our circle up and down. So anything added with y in parentheses is our shifting our circle up and down. Because it's in parentheses, we always go opposite of the sign. And then it's still equal to our radius squared.
So when you mean like opposite of the sign, does that mean if h was like 8, negative 8, we'd go right 8?
Right, so yep, good point. So if this was negative 8, we would go right 8, positive. So that would be 8, right? So our center would be at positive 8. Do you see how this is the opposite of these? And then if we're going minus 7, that'd be shifting it down 7. We'd go opposite, so it would be up 7. So it would be positive 7. So that's why our center is at h, k. It's at positive h, positive k, because we go the opposite. So it will make more sense when we start practicing, I promise. Same look on first hour space. They all thought the worksheet was easy, so just, I know what I'm doing here, just bear with me. Does everybody at least have this written down? Okay.
What is H?
So that's going to be the new center of our circle. Because we shifted right H, because we go opposite if it was negative, and then up K, because we go opposite of negative, which would be up. So H comma K would be our new center. We went right, if it was negative, right H, up K. And then our radius squared is on the end. Not radius. Don't mistake this for radius. This is radius squared. Okay, so here's my first example, guys. Here we go. So it says, write the equation of a circle with the given center and the given radius. So my center is no longer at 0, 0. It went over 1, down 2. So I'm just showing you a picture. Over 1, down 2, right, everybody?
Right.
Okay, and then we have a radius of 3. So I'm just showing you what's happening. 1, 2, 3, up 1, 2, 3, over 1, 2, 3, down 1, 2, 3. And we could draw in it's hard to draw in a circle by hand. Okay, so now we're going to write the equation. So we know it's going to be x. Did we shift left or right? Left and right. That's what's out with x. We went right 1, right? So we have to do opposite. So that will be x minus 1. The squared part's what makes it a circle. Now look, isn't this the opposite of what we were given as our center? Isn't this the opposite sign? It's always going to be that way. So we have x minus 1 squared plus parentheses. What was our shift up and down? We went down 2, right? So it's going to be add 2. Y plus 2 squared. If you forget the squared, it's not a circle. And that's equal to our radius squared. So it's equal to 3 squared. What is 3 squared? 9. So I'm not going to write 3 squared. I'm going to write 9. Is equal to 9. And there's the equation of my circle. So we know we went right 1, down 2, because you go the opposite. Does everybody understand that one? Let's look at another one. Yes? We wrote the equation of the circle. Okay. Next one. Center 0, up 3. So we went from over 0, up 3. Then I had a radius of 1. So I went out 1, up 1, over 1. We have a circle with a radius of 1. All right, so now we're going to draw our equation here. So what was our shift left and right?
0.
0. So x plus 0 squared, right? And then plus, what was our shift up and down? Positive 3, right? So we always go opposite, so it'll be y minus 3 squared. And that's equal to our radius squared. Our radius is 1 squared. Now we need to write this a little bit prettier. X plus 0 is just x, right? So let's not write x plus 0, let's just write x. So x squared. So we have x squared plus, we'll leave this as this, y minus 3 squared is equal to, what's 1 squared? 1. This is our equation of our circle. So you can see there was no shift left and right, right? Nothing added with x. And then we went up 3. You go the opposite, you write it as the opposite, yes.
How 0 is going to be addition?
It won't matter because if I would have wrote minus 0 when we simplify it, it would still be just x. Good question. Yeah, great question. All right, any others? Okay, one last one and I'll let you work. I'm not going to draw the picture this time, let's just think about it. So it says it has a center at -4, -2. So -4, -2, right? So let's write our equation. We always go opposite. This is our shift left and right, right? So if it's negative, it's going to be x plus 4 squared. Plus, don't forget the plus sign in between. And yes, this will always be a plus sign. And then we shifted down 2, so it's always the opposite of that sign. So it'll be y plus 2 squared is equal to 3.5 squared. Take your calculator if you need to and go. Parentheses, 3.5, parentheses squared. You get 12.25. I'm going to change it back to a fraction. So I have x plus 4 squared plus y plus 2 squared is equal to 49 fourths. There's the equation of my circle. Are you ready to go on your own? Okay, do problems 1 through 6. I need you to go quick. And here we go. So it says, write an equation. I'm doing number 7. It says write an equation for each translation. So we are at x squared plus y squared is equal to 9. We're at no shift left and right, nothing added with x, no shift up and down, right? So we're at the center right now. We're now shifting right 4, so that would be 4 comma down 2. Wouldn't that be 4, negative 2? Is everybody comfortable with that? If you took the center of your circle, went right 4, down 2, wouldn't it be that new center, 4, negative 2? Okay, so now I know the new center is at 4, negative 2. So I do the opposite with the shifting left and right? So with x, it'll be x minus 4 squared, right? Opposite, plus y minus 2, we went down 2, so it's going to be y plus 2 squared, and that's still equal to 9, because our radius was 3, apparently, and so it's still equal to 9. We just took the center of the circle and shifted it, right? So we're done.
Yep.
Okay. One more. Number 8. So once again, we're starting at the center, and we're going to, you got to make sure which all of ours are starting at the center, right? I mean, if you look at them, there's nothing already added or subtracted, but just watch for that. But for right now, we're starting out pretty basic. So we have no shift left and right, no shift up and down, but now we're going left 2, up 5. So that would be negative 2, comma, positive 5. So added with x will be x opposite, so plus 2 squared plus
Y.
y, you go opposite, so minus
5.
5 squared is equal to 12. There's our answer. So pretty basic, right guys?
Right.
Okay. So now I want you to do 7 through 12, and I need you to be quick but prompt. Quick but good. Don't make any errors. Common mistakes, but they're not any harder. It's just students kind of, even I messed up a few times. So you just got to be careful. So it says write an equation for each circle. So I'm going to do number 13 with you, except for actually it's not number 13 because mine's drawn different than your number 13. So just look at this as an example. So first of all, to write the equation, I want my center and I want my radius, right? So what is my center at? Negative 5, negative 3. Does everybody see how it's at negative 5, negative 3? Now my radius, this tends to be the hardest part for students because they kind of, especially where yours don't have the tick marks like mine. Remember, radius is from here to here, right?
4.
So like make sure you draw up and count like this. Do you see how I'm counting the physical units of movement? That was making it harder than it used to be.
Yeah.
4 units this way, right?
Yeah.
Okay, so 1, 2, 3, 4. So my radius is 4. Okay, so let's plug it into the equation here. So we have x, we went opposite, so plus 5 squared plus y opposite, so y plus 3 squared is equal to our radius squared, which is 4 squared, which is
16.
16, and we're done. So do you see how to do it? It's just hard because your guys' pictures don't have the tick marks like mine do. So just make sure when you're counting the radius, you're really careful, if that makes sense. Yeah, that's all I wanted to get at. Just be careful when counting the radius. Okay, sweet. Do 13 through 18 go. So, next thing, it says, for each equation, find the center and the radius of the circle. So I need you to pay attention for this one. So, pretty easy to find the center. It's we went left 1, right? Opposite, guys? And up 8, opposite of that, right? There's my center. So that's my center. Now my radius is, you've got to go out to the side. This is not the radius. That's my radius squared. So radius squared is equal to 1. How do I solve for radius?
Square root.
Square root. What's the square root? So root cancels out power. Radius is equal to 1. We don't have an error in
Would you write it
class.
1 squared? So
So radius, no. We want to know what's the radius. The radius is 1. This is radius squared. So our radius is 1. Okay, let's do another one. In the equation, you do write it as radius squared, but we're asked what's the radius. Do you guys all understand that? Okay. So with this one, my center is at anything left and right. 0, 2. Now that's not my radius. That's my radius squared. So I say, I know my radius squared is equal to 64. Therefore, my radius is 8. So this is my center and my radius is 8. Pretty easy, right?
Yes.
So what if you get one with us for like what if this was 5? So radius squared is equal to 5. Then what's my radius? Square root of 5. Very good. All right, so do 19 through 24. All right, yeah. Good job. Okay, I'm proud of you. All right, so here we go. It says use the center and the radius to graph each circle. So you all should have picked up at least one sheet of graphing paper, did you? If not, go grab some real quick. So you'll want to give yourself some room on some of these because your radiuses are kind of big, but I want these circles exact and beautiful. So here we go. It says use the center and the radius to graph each circle. So this would be 1, -3 is my center, right? But don't forget, that's radius squared. Don't graph that as your radius. So r squared is 9. So then r is 3, right? Radius is 3. So I go over 1, down 3, and then from there, my radius is 3. So I'm going out 1, 2, 3, up 1, 2, 3, over 1, 2, 3, 1, 2, 3. So I need you drawing your circles on that graphing paper. Okay, when you're done, staple the graphing paper to your paper and hand it in.